Guys, very good morning and good evening also. And let's continue with the next part. Today, guys, I'm going to take the cryptography at the next level, right? And it is very important topic. I don't know whichever field you belongs to, whichever kind of network or server setup you want to perform. Okay. For example, maybe you want to set up a web server that, let's say, Apache web server or HTTPD product. Okay, so you want to implement your website from HTTP to HTTPS for encryption. This is what the demonstration I'm going to show you today. Or maybe you guys are working in the load balancer. Let's say you set a load balancer with a product called HA proxy or maybe other products. Okay, so between the client and the server, we have a load balancers. Okay, and I want all the traffic from the client to server and client to load balancer will be encrypted. Okay, this is called TLS or encryption or SSL terminations. So either you want to go for TLS SSL terminations concept or pass-through concept. Okay, this area also you go. You should know today's class in very detail. Okay, so plus those who are learning the cryptography under me from last couple of classes, I feel this will be your last class. A lot of concepts guys we already discussed over there, and today's class the prerequisite would be, okay, what a class you guys you have learned from last few classes in cryptography, you should know it. Okay, maybe I will quickly give the brief those who by chance miss it. Okay, but at least last two classes of my cryptography you should know, where I talk about digital signature, asymmetric key or symmetric key. At least if this concept you know, you can understand very quickly. Otherwise, the way I'm going to explain the today's class also, there might not be so much link. You guys can understand very well. Okay, but today I'm going to explain you very important detail and big class I can say about public key infrastructure. How can set public key? Where I'm going to explain you how to set a chain certificates or chain CAs, where you have the root CA, then we have an intermediate CA, then we have server certificates. We talk about CSR, we talk about CRT, how to sign, how to get your own personal CA. Okay, and according to me, the depth and the detail of the today's class will be so insane, so big. I don't think so. None of the cryptographic classes, okay, going to give you a very detailed explanation with 100% practical that I'm going to discuss today. So, so those who was with me in cryptography and register in the cryptography, right? If you see the agenda, okay, I'm going maybe 1,000 times more deep and content what we have in the agenda, right? So you can think that the detail and the complexity of today's class, right? But it's very required, very important. Okay, if you don't know what is bundled, what is chain, what is root, how to create a intermediate CA, what is role of intermediate CA, what is extensions here, what is policies here, how to create your own CAs. Okay, what kind of attacks is possible, what are the concepts we know till date. Okay, what is, even though I'm going to talk about TLS 1.2 also, but nowadays guys we have one more new version of TLS going to come up, right? That's very new. TLS 1.3 also. What is what TLS 1.3? So we are going to discuss in today's class. And all this concept you know, okay, without knowing this concept, you can't do anything in any kind of web server to convert to HTTPS, or you can't able to do good in the HA proxy or any kind of a load balancer, because if you don't know how to work on the cryptography, then setting up the load balancer with encryption and between server and client encryption also won't be possible. We can do with 2 or 3 commands, but what is happening would be very harder. So today's class give you lots of detailed understanding of this particular topic. So let me explain. Well, let me go to this topic. Okay, And by the meantime, also let me also launch my one instance so I can do lots of demos there. Okay, guys, today you will see a lot of commands gonna come up. Believe me, there's a lot of commands, a lot of big commands gonna come today in this topic. Um, okay, but I will explain every bit of it, so don't worry about this point. So I'm going to launch one Red Hat version 8 operating system to do this demo. And today I'm going to set up one web server and how to show how to encrypt the web server. That will be one of the final practical demo for this, but this will be a entire PKI setup we are going to do and enabling all traffic so that nothing will block because of firewall. Okay, so this is when we launch, and now you will see how the thing works. So very quickly, guys, let me give a quick revision of in 5 minutes of my last classes. Okay, so between the client and the server, if you want to perform the encryption, one of the way would be symmetric key, where client can generate one key with the help of symmetric, means same key, or this is also known as secret key, also known as shared key. Okay, and this shared key, because client want to communicate with server, so I want to come to client encrypted way, same key client can share to the server. So server will also have the same key and they can encrypt the remaining traffic. But the challenge in this process is at this point in time where client is sending the key, and same point of hacker is listening to the network. Okay, this concept is called eavesdrop. If they are doing eavesdrop, okay, they can also see the key and also copy the key. It means after some time, this client is, and server is doing encryption, because hacker also have the same key and they can also decrypt and see the data. So asymmetric we symmetric, if you use only symmetric key encryption to doing encryption of the data in transit network data, won't be the right method for this. We can very easily break this setup with the eavesdrop. Okay, so the challenge here is how can we distribute the key? So key distribution was the challenge. How client can distribute the key, or server can distribute the key to client. To solve this, and guys, we have moved to discuss concisely or explain my word very detailed. So we move to a concept called asymmetric key, and we can use asymmetric key for the key distribution. Okay, and what the idea would be, I will explain to you. So again, this is the client and this is server, where somebody, mostly in this case server, is the one who create a private key, and same private key we can drive the public key, right? And if any client want to communicate to the server before this, okay, client will connect to server and say, I want to communicate with you. Server will send their public key to the client, Now client has a server public key, or maybe at this point in time, hacker again is doing eavesdropping in transit data. The data is transmitting here. Okay, a hacker can also only copy the public key, but public key, guys, there's no use of the public key, because if any data is encrypted with this public key, you guys know nobody can decrypt this. For this, we need a private key, and private key won't be shared on the network ever. It's been only kept by the server. This one, so you know already. Now what client will do, only challenge asymmetric is very slow. So further communication we always want to do in symmetric key, because symmetric is very quick. I show you in my last class the performance testing on both the keys. So my client will go and generate a key that is just called kind of symmetric key. Okay, and this symmetric key is been logged by a server public key, and this data will be sent over the network. Okay, hacker can see it, the secret key, this is called symmetric key, but they see with the logged, this is called encrypted. But hacker don't have the server private key, they only have the server public key, because they can eavesdrop and copy it. But with the public key, they can't able to decrypt this, so they won't able to see this data. only the data when the server reach to server, because server has a private key. So with the help of private key, this part will be decrypted and server will finally get the client key. It's not a client key, it's like a secret key or the shared secret key or symmetric key. Now both the party has the same symmetric key. Symmetric key is very powerful in terms of security, and they are also very fast. Now further communication between the server and client happen with the help of symmetric key. So we use asymmetric key concept, okay, for the key distribution part. So what challenge we are facing in the symmetric key, where it can be solved with the help of asymmetric key. And this concept, guys, I told you in my last class, is known as hybrid key setup. So this was the last topic as what we had discussed. But I told you guys this setup can also be breakable. And this is one of the tasks I had given to you. How can you break this setup? Okay, this setup can also be breakable. It look like very powerful, but this can also be breakable. How can we break or hack this setup? Okay, so let me explain guys how can we break this. So if to break this asymmetric and symmetric setup, that is called hybrid key setup. How can we break? Okay, so for this, let's say same example, client is here, server is here. Let's say server IP is 100, let's say client IP is 2, for example. Okay, the hacker is sitting over here. Okay, so we have a network connections between client and server. Okay, but there's a way available in the market where a hacker can do some kind of poisoning attack, or it's called root poisoning attack. Oh, and you know what happened in the root poisoning attack, right? If client want to communicate with server, right, then client data have to travel first to the hacker computers, and from the hacker computer they will forward it to the client, to the server. Okay, so maybe hacker may be there somewhere in the ISP on the internet as a router, they're sitting over here, or if they're not sitting over here, they may be at the home location. But there's a one concept called root poisoning attack. They can forward the client packet, okay, by routing their packet from client on both server side also, okay, from their computer and from their server. Okay, now in this case, what hacker will do? Let's say this setup is possible very sometime very much easily. Okay, after they achieve a hacker achieve this setup, then hacker client packet will move from the client to the hacker computer. Then hacker will do something on this packet over here, and then they send back to the server. Now what hacker will do? Okay, in this case, hacker will do something like this. Server already have the server private key and the server public key. Okay, similarly, hacker will also create their private key. That's anybody can create, nothing big deal. And hacker public key also. Okay, and when client trying to connect to IP 100, okay, hacker will make their system in a such a way that any packet come to hacker will say, hey, I am the IP 100. This is called IP spoofing. Even though this is not IP 100, but they pretend and say that I am IP 100, I am your server. Sometimes in this market, this attack is also known as phishing attack. So they do the phishing attack over there. Okay, so what happened when the client hit first time, they hit to this system. And obviously, client never know where they hit. They only know the IP address. And hacker say, hey, I am the IP 100, even though they are not, but this I am the IP 100. Okay, and client say, I'm looking for security. You are my server because your IP 100, but this is IP 100 here. They change it. Okay, and you are the IP 100. So I want a security. Can you give public key of yours? So client hacker will give their public key to the client. So client finally reach and get the hacker's public key. Okay, now client will generate one secret key. This is called shared key. That's the client key, for example. And now this key been encrypted by the hacker public key. Okay, and sent to the same system again, because the route is going in this way only, send over here. Okay, and now this time this key is been encrypted by hacker public key, or because hacker has obviously they have their own private key, so hacker can very easily decrypt this data and get the client key over here. Okay, now but at this point in time the hacker doesn't get much thing over here. So after they get the client key, that is called kind of secret key. Okay, what hacker will do now, hacker will initiate one more connection from their system to real server, actual server, and pretend and say, and I am your client, I am looking for to connect to you. Okay, and server will again send the server public key to the hacker. Okay, and hacker will for further communication, they will share the hacker secret key. But in this case, hacker won't create their own secret key. They will share this secret key, whatever they collected from the client. Okay, and log with the server public key. Okay, and then this information sent to the server, and now server will unlock, because it's been locked by server public key. Server has their own private key. Server will unlock, and they will get the same secret key. Now, in this case, client has the secret key, server has a secret key. This was shared semantic key, and client hacker can also get the client secret key or the shared key. But till now, hacker doesn't get much thing, neither client data, neither login and password, but hacker has the same shared key that is being created by the client, and they want is to be used by server. That's what I show you here. The common key, shared key. Hacker also achieve it by this way. Okay, by sending the packet via their system. This way, now further communication client and hacker, maybe in this case now hacker is not the real web server. Hacker have no login and password of the client. Let's say this is the Gmail system. So hacker system is not Gmail. They don't know the client login and password, know the data. Okay, but after they get the key, now all the further communication hacker can send as it is. Any client will send the data. Okay, they will now this packet hacker will don't take in their own system. They will route it like a normal router. That's called concept of forwarding. Okay, and for forwarding, they will use the same secret key for encrypting it. It means now further communication of client and server may login and password, remaining data, mail, everything is being go via hacker system, and hacker has the key to unlock it, and they can unlock and see the thing. Okay, now this is very, very much possible, and this attack is known as man in the middle attack. This is one of the version. Okay, and there's a multiple different scenario, and the multiple different variant of this version is also available. Okay, so motto here is this is not the hacking class I told you multiple times, but this is one of the variant of this attack. Otherwise, lot of small changes we can do here. Sometimes hacker will work as a proxy here. Sometimes hacker will forward the traffic. Multiple different variant we have depend upon setup to setup. But with the help of this concept, actually, MITM attack is can be achieved. So your entire setup of asymmetric encryption with your symmetric encryption, that's called hybrid, can be breakable. So this is one of the big challenge we have. Okay. So again, guys, challenge. Why we have the challenge? Because on the internet, client is connecting to server. Okay, client only know one thing, that is the IP address. That's all. So right now I'm connected to Facebook or the Google system. All right. So I know the IP address, or let's say the DNS name, same, almost same thing. I know only one thing, right? How I know the system IP address I connected is a real Facebook. Somebody created a same copy of it, because creating same copy of Facebook was no big deal. We can download this page very quickly and clone this page. We have tool available in the market. 1 minute, entire website we created. So how I know this is the real website? Okay, because changing on the IP address somebody is very simple. Getting a same exact website, web page is very simple. Okay, and by doing some root poisoning attack might not be simple, but is work possible. We can do it. A little bit access we have, we can do it. Okay. So the challenge in the client is, okay, the client has no way actually to check, because I as a client, I can't go physically to Facebook data center at this point and say, hey, I connected to you or somebody else in between, and the man in the middle. Okay, there's no way. We only understand the IP address, right? We only rely on the IP addresses, right? And because of IP spoofing, what client has changed their own IP address, same IP or same name, IP address, the spoof, and we connected to the wrong place, and further combination happened, right? So how can we solve it? So here the big challenge is we can't rely on the IP addresses. Okay, so to whom we rely on, right? We can't rely on the symmetric key sharing also. Okay, we thought let's start with public key asymmetric key sharing, then set the symmetric key hybrid way. Again, this is not been reliable. So this entire setup, what we are doing here, okay, of how can we rely? We know key is powerful. The only challenge is from wherever we are getting the first key, the key distribution is the challenge. Initially, we was distributing symmetric key. That was a challenge. Eavesdropping happened. Then we try to share public key. By looking at public key, nobody can do anything. Then again, the distribution of public key also been challenged, because when client connect first time, okay, the connected to hacker, and hacker give their public key. How client them to know this is the public key of real server and the real Gmail system or real hacker? Okay, because client rely this is a real public key, because there is nothing is there inside the key to understand, okay, this key actually belongs to Gmail, or this key actually belongs to hacker system. This key is just a data. Client think this is a real key. They give their key data private, they know symmetric key, and hacker use the symmetric key to the remaining part. Okay, the challenge is still, even though we have a symmetric, challenge is, okay, challenge is how can I distribute my key, especially the public key here? Okay, because if client is getting a public key from somewhere, there is no guarantee this public key is belong to real genuine server, or this key is belongs to hacker. Because in the key, there is no way to check this key belongs to a real server or hacker. Yeah, if this client get the real key from a server, then this setup is very powerful. Which setup? Asymmetric key kind of setup. Okay, if the client get the real public key, then further communication of sending the symmetric key, because only server has the private key, so that setup can't be breakable. Okay, if client get the genuine public key in the one go, and first go. Okay, when they connect first time. Okay, either one possibility would be, okay, one possibility, client can go physically travel to this data center, ask them to give the public key, put in the pen drive, and come in the own system and copy in the laptop. Okay, then and in initial communication, they don't ask for the public key. They say, I already have the public key. Now let me do the further thing. Let me create a shared key and give with your public key. If you do so, then it's a powerful setup, no doubt. But obviously, practically it's not possible, right? How can millions of people go to Google and get the public key manually copied? Okay. So point here is, final challenge is we have to create some kind of way where if client get a public key, by looking at the public key, client can verify, okay, that this public key is actually coming from the actual one, from Gmail, from Facebook, right? We need certain mechanism. We need to create some kind of setup or some kind of infrastructure for this. And that this is called PKI, public key infrastructure. We will create an infrastructure for the public key, because after getting the right public key by some setup model or some kind of protocol, some way, okay, then everything will be, after this, everything is so powerful. Okay. And for this, what we have to do, okay, only possible way, if you try to understand, only possible way is we have to trust on some third-party company. Third-party company. So some third-party company we have to trust on. And we have to give this authority to this third-party company that you will go and verify this public key belongs to actual server, let's say Gmail, or it's not belong to Gmail, it belongs to hacker. You will verify for us. Okay, so I as a client come to you, okay, and you will verify, either just tell me yes or no, or you can put some stamp on it, okay, and say this key, what you get, public key, is actually belongs to a real server. Okay, so you have to give the stamp to me. It means you have to verify for me. Okay, and this third-party company is normally known as certificate authority, CA, certificate authority. Guys, I'll explain this concept in very detail how it should work, but I'm just trying to tell you, okay, because the challenge is, okay, client can't travel to Gmail data center and copy the key in the pen drive. Okay, only way client can get the public key by network. But there's no guarantee from wherever they're getting the public key initially, they might be hackers' public key. And if they get the wrong public key initially, then the entire combination will be hacked by hacker very easily without any issues. Okay, so only challenge that is we have to solve is first time when they're getting a public key, our client needs somebody who verify that public keys belong to same company. Okay, here the third party guys we need, and it's called CA, certificate authority. How they verify and what they do, that's what the detailed discussion I'm going to discuss. Okay, I'm going to discuss. So let me explain you this concept with very detail. Okay, and this concept I will lead you to a concept called SSL TLS handshaking also. What are this? We will see in this diagram. So let me explain this concept in very detail, how this will work. So let me draw this diagram again. Okay, and this diagram is very important, and this will be the conclusion of our cryptography classes. And this is what the entire cryptography or entire encryption setup is done across the world. Our internet or entire internet is actually being relied on this infrastructure that is called PKI. Okay, where third party we have to rely on. So let me explain this concept. So this is the client again. Let's say this client. Okay. And my client is, let's say my client is my laptop browser. This client we have. Okay. So let me use the word called Chrome browser here or Firefox here. So I'm the client. Chrome browser the client. And I'm connected to Google system, or let's say Gmail. Okay. And Gmail is server. So Gmail server has their own server private key and server public key. Okay, but Gmail no, man in the middle attack is possible, IP spoofing is possible, all the attack is possible. So there's a possibility if client come to me, I can give my real general public key. There's no big deal. But challenge is if somebody is in middle or doing some kind of MITM proxy attacks or something like this. Okay, so sorry, something like this. Then if my client is not able to come to me, how can I give my real public key? So only challenge is to share my public key to the client. Okay. Only if I can share if they come to me. But if they go to wrong location, like a hacker system, okay, at least they might not able to reach me. Okay. Or maybe my connection might not be available. There's a issue of availability. But at least they won't hand it over their symmetric key to the wrong person. That's what we have to say, guard our clients. Okay. So for this, what we have to do, these server like say Gmail, okay, and the client, both the computers has to rely on some third-party company or third company that's called some trusted authorities. Okay. And typically they are known as CA, certificate authorities. Let's say I'm putting name CA here, certificate authority is a third-party company. Okay. One example may be DigiCert. One of the example may be GoDaddy. So let me put the GoDaddy here. GoDaddy is a one company who work as a third party, work as a CA, certificate authority. And this is the company where both the companies rely on. Gmail also rely on this company, and client also rely on this company. Now, how the process work? Okay. Now, in this case, okay, Gmail want to share the public key. Okay. So this is the motto Gmail want to share to the client. Okay. So what Gmail will do, okay, Gmail will create one file, one document. Okay. In this document, Gmail will put the public key. The public key is just a data, right? Okay. But Gmail will also put the company details. Okay. What is the company name? Okay. What is where this company belongs to, their address, and much more things. They put their company details and they create this one document, and this document, guys, is known as a certificate. Actually, they create one certificate. Okay. And this document Gmail send to the CA. Why this CA? Because this is one of the CA, certificate authority, where Gmail is also rely on or believe on, and all the clients in the world, may Windows, Linux, your mobile phones, your laptops, your applications, your browsers, everybody rely on this CA. How? That's a different point. I'll tell you in some minute. But let's say we rely on, we believe on this CA, that this is genuine, it won't gonna do anything wrong. Okay, there's a trusted one. Okay. Now, what this CA will do, what they say, Gmail will say this CA that everybody rely on you, as a, let's say GoDaddy, everybody rely on you. So do one thing. I'm requesting you, I'm sending my certificate. Okay, so I'm requesting you, just go through my certificate. Okay, go through my certificate, and in the certificate, just check my details. I'm putting all my company name and details. Maybe you can come and visit my company to verify all this details is sent by me only physically, because anybody come physically, we can't do this kind of network attacks. Just verify the certificate, maybe come to physically. Okay. And after you feel everything is good, you do one thing, just put a stamp on the certificate. Okay, put your stamp, because everybody believe on you. If you put your stamp, okay, in this certificate, a stamp, guys, in the digital world also known as sign. If you put your sign on this certificate, okay, then I can tell everyone in the world, okay, that my certificate that I created is signed by GoDaddy, and everybody believe on the GoDaddy, then something we can do. What something we'll see. Okay, so I want you to sign it. Okay, then we can do something. So guys, in this process, the certificate that Gmail or a server is being created, this certificate is known as CSR, certificate signing request. Because CSR certificate, and CSR certificate has been sent to your CA. CA will verify, depend how they want. They will verify. There are multiple methods they have. they might come to your setup physically and come here and verify. And there's other more way also available to verify these certificates. Okay, well, let's say somehow they verify this certificate. Okay, after verify, they sign it, and this signing on the certificate, okay, is file known as CRT. CRT name is a little bit different actually. Is Chinese Reminder Theorem is a full form of it by chance, but CRT normally means certificate that has been requested by some company, some server, and some of the C has been signed, and the format of the certificate is known as CRT actually. But CRT means some certificate has been signed by some CA. And guys, in signing, guys, because this is a digital one, so they use a digital signature. What is digital signature? I told you in my last class already. So they use some kind of DSA and some other kind of mechanism, or ECDSA, ECDSA kind of protocol to sign it. Why digital signature? You guys know. Okay, if anybody signed the signature, it means by looking at the certificate, anybody can verify digitally that this is signed by GoDaddy. Nobody can sign apart from GoDaddy, because you guys know, if any document you have, or any file you have, or any document you have, if it's signed by GoDaddy, okay, so by looking at the digital signature, okay, we can very easily find out that is being signed by GoDaddy only. So we can very easily verify. Why? Because signing is done only by private key, and if you are GoDaddy, so GoDaddy have their own personal private key that is not shared by anybody in the world. And every system or every CA in the world have their own personal private key. Okay, and private key use is for one more purpose. I told you in my last digital class topic that if you have the private key and if you sign the document, okay, so anybody can verify your document. How? By your public key. So CA shared CA public key to everyone, and anyone who want to verify the certificate, they can verify with the CA public key that this document is been signed by the CA only, GoDaddy only. Okay, so this signature also I will explain to you, but here this is one of the use also. So GoDaddy is one company everybody in the world rely on. This is a trusted company, trusted company. Okay, but when the GoDaddy or let's say CA sign the certificate, how we know this is certificate signed by GoDaddy only? Because there's a possibility hacker can also create their own company. Okay, and they can also do a setup like CA, because I told you so today in today's class how to create a setup CA. The creating a CA setup is not big deal. This called setup authority, technical setup is not big deal. Hacker can do it, but hacker won't have the private key of the GoDaddy actually. So by chance hacker sign some certificate or as a fake certificate, okay, then anybody in the real world, okay, who know GoDaddy, okay, by looking at the GoDaddy public key, they can verify this is not actual GoDaddy, or it has been somebody fake. They're trying to do these things, right? This one thing. So there's one part of it. Now, in this entire process, what I'm trying to tell you here, a process. Now, Gmail finally got, okay, one thing, they will get their own certificate that's called server certificate. Okay, but this certificate can be created by anybody. Hacker can also create the same certificate. Okay, but the big thing is this certificate is being signed by some trusted CA in the world. Okay, trusted CA in the world. In our case, for example, is a GoDaddy. Now, what I mean by trusted here? Okay, what am I trusted here? Okay, trusted means those CA in the world that is been known by anybody in the world. Anybody doesn't means human being or any website. Anybody means any devices in the world who is doing any kind of internet transaction or internet communications or network communications. Okay, so it may be a Chrome browser, it may be a Safari, it may be a Firefox, it may be a Windows operating system, it may be Linux operating system, or Mac operating system, a mobile device, Android, iOS, any device or program and software who are doing any network communications over the network or the internet, they trust GoDaddy. GoDaddy is one example. Okay, they trust GoDaddy. And GoDaddy is one example. There's a much more CA available. Okay, why they trust and how they trust. Okay, trust is very simple. They say if GoDaddy is one company, okay, this is the individual company, they have their own personal private key. They are not going to share this private key with anybody in the world. Any data that's called document comes to GoDaddy, they use their private key to sign it. Okay, so this document, what comes to GoDaddy as a request for signing, this document finally will be verified or signed by GoDaddy. This sign is called digital signature. Okay, now anybody in the world want to verify this document. Okay, this document is actually signed by GoDaddy or not. Okay, anybody, for example, me, Vimal, want to verify. I only want to verify only one thing, that this document is signed by GoDaddy or not. I can verify only if I trust GoDaddy, and this trust is equals to if I have a GoDaddy, which may be wrong, public key. So if I know the genuine public key of the GoDaddy, okay, if I have the real public key of the GoDaddy, okay, then it means I trust GoDaddy because I have this public key. So I can use GoDaddy public key. Like I told you my digital signature class. If somebody signed the document with their private key, so public key of that guy, because GoDaddy has own public key of the GoDaddy can be used to verify. Okay, this is signed by actual GoDaddy or not, because sign is only done by private key. What is it? Digital signature only done by private key. So anybody who has a public key, they can verify they're signed by GoDaddy or not. It means if I have the GoDaddy public key, I can verify. The challenge here is, again, guys, the challenge is public key only. How can I get the GoDaddy public key? How can I get it? Because if I try to go and get the GoDaddy public key, okay, over the internet, so there's a possible again MIT attack. Okay, some hacker is sitting in between, and when I try to get the GoDaddy public key initially, hacker say, hey, I am GoDaddy, get my key. Or same hacker is the one who will sign the document that they put in their own hacker servers to do the same thing. What I'm trying to explain. I will explain this point again one more time when the complete flow, but I'm just trying to connect the dots and going to show you the multiple things, then I connect the dots in some minute. Okay, so point again here is, okay, we are signing our certificate so that Gmail will share the public key to the customer. So customer, while looking at the server public key, if they see this public key is like a document, okay, and this document, they before they use this public key, they will check this public key signed by CA or not. Okay, this client here is like a me here, Vimal, what I created here. This is this in this example, this Vimal is like this client. This is your Chrome browser. Okay, so when the Chrome browser get a server certificate, when this client connect to the server first time, my Gmail will give the server public key. How my client know this public key is actual public key by Gmail? Maybe some hacker put the public key as a MIT attack. So in this case, client will check the sign. Okay, check the sign. Okay, the sign is by some trusted party or not. But for the client, who is trusted? What do you mean by trusted? GoDaddy, but how GoDaddy is trusted? Okay, for this client need a GoDaddy public key. At least some public key they need for to verify Gmail public key. Client is checking the sign of GoDaddy. For checking the sign of GoDaddy, client again need public key of GoDaddy. Public key of the GoDaddy. Okay, but some public key we need. So in this case, maybe can we add one more trusted company here? I can put one more trusted company, let's say one more CA. And the same product I can do GoDaddy. If you want to put send your public key, okay, to the client, why you want to send your public key, you are the GoDaddy to the client. They don't want to communicate with you as encryption data, but they need your public key because this document of Gmail has been signed by you, and to verify the signature, my client need your public key, which GoDaddy public key. But there's a possibility when you are sending your public key, hacker might come again in between and they will remove this part and send their public key. Or before, they also share the wrong document of hacker own certificate. So hacker is the only one who created the Gmail fix server. Hacker is the only one who created a GoDaddy fix server. Everything is created by hackers. So hacker first send the Gmail wrong certificate, then send the wrong CA certificate, and obviously everything belongs to hacker, has been verified, then that almost the same. We reached the same issue what we started with. Okay, so how can I verify you that you are the genuine CA certificate? So for this, we can create one more CA certificate on the top of it. Okay, and again, to give your genuinity in the real world, you will go and get your certificate. Okay, so don't send your public key directly, send your CRT certificate, this certificate signed by other CAs. Okay, but again, same issue come up. This CA say, again, my client want to verify this CA, again, this CA want to send the public key. How can they send? Again, they will go and send by other trusted guys. There's a long chain actually. There's chain of CAs we have. Okay, but we have to reach to final point. We can't create one by one a lot of CAs connect together. It's called chain of CAs to finally verify. We have to come with a final solution for this, right? And final solution would be that entire internet, entire companies, entire communities of all the operating system, all the mobile devices sit together and they say, do one thing, create a top level CA, this is called root CA actually, and fix some companies' names, fix some company name. Okay, and do one thing, only challenge is, okay, getting the public key initially. Okay, if you have the general public of the root CA, let's say I'm giving a name, DigiCert, for example, or maybe giving a name, maybe VeriSign, just for example, is one company who is like a CA. Okay, so I am working in my Firefox browser. Okay, any data come to me, any document come to me, mostly known as certificate. What certificate content? Intent certificate. Actually, main thing is public key come of your actual server, let's say Gmail. So I have to check this certificate coming with a public key is signed by CA or not. Okay. For this, I need a public key of a CA. How I get it? Okay. So one way is the way I'm trying to explain you. You will go and download. Okay, get it. Again, same issue gonna come up. Hacker can send the wrong CA certificate. Okay, so only way to get it is all the programs in the world like Firefox, Chrome, or operating system, they have to give this public key pre-installed in the programs. Every operating system, devices, platform, softwares, browsers has to give pre-installed public key in their system. Okay, so don't download and don't get from the internet. So if I have Chrome browser with me, so inside this Chrome browser, all the CA certificate in the world I have already. I don't have to download. Neither when I do any first communication to anything to anybody. In the first time also, when you all launch your operating system first time, you don't have to get from the internet. It should be pre-downloaded or pre-copied in your operating system. That's the only way to read off this issue. And that's what is happening in this world. So according to PKI infrastructure means the public key infrastructure has already been set up. All the operating system devices has given the trusted CA certificate. This is called public keys actually of the CA is been installed in your respective browser, for example, or operating system, for example, or mail program, mail client program, for example. Okay, in this. So that first time they have some public keys. Just for example, I'll guys talk about root CA again. Okay, after knowing this in this part, then I connect the dots, then you can understand the entire flow in a minute. Okay, so if I open my Chrome browser, if I go to settings or go to Firefox and settings, okay, over here, and if I try to search for certificate, and here you will see the options called security in a browser. If you go down the security, you will find manage certificates. If you go to manage certificate, there's option called trusted root certificates here. Okay, and that there are some top few companies in CA in the world. It's called DigiCert, for example. This is DigiCert. Or if you go here, GeoTrust. If you go here, IdenTrust, Hotspot, GoDaddy. And you pick the GoDaddy here, for example. Okay, so this is the GoDaddy certificate. To make it simple, this is the GoDaddy public key. If I click on this public key, means as a view of the certificate, there are a lot of things there we'll see on those things. But if you see in the details, okay, this is the public key of GoDaddy. Okay, and we don't have to download this public key from the internet. It is inbuilt there inside your browser. Okay, if you're using browser, otherwise it will inbuilt inside your Linux operating system or your Windows operating system of the GoDaddy. And that means any certificate that is inbuilt that you have already as a public key, especially not other things also there as a public key, especially. Okay, so I can say GoDaddy is trusted. I trust GoDaddy. I trust Microsoft. But Microsoft also have a working as a CA also. I trust Kudos, Redis, or Secure Trust and Starfield. Lots of names we have in the market. So all the top level certificate authorities for CA is a third party company. Okay, they are so trusted, so reliable. Okay, maybe have some kind of security compliance also they have to follow. Okay, that all the companies and their software browsers in the world, they trust it and they give you. So when anybody create a Chrome browser belong to Google. Okay, at that point in time when the software created, they put inside the certificates. Okay, what a certificate, don't keep the word right now certificate, we'll discuss more. Let's say they keep this, the public key inside this program so that you don't have to download from the internet. Okay, so it means these are trusted one. It's not in your Firefox, exactly same if I open your Firefox or Chrome or Safari or mobile operating system, Windows operating system, mail clients, everywhere, these are the some few name available. Okay, so this is one point. Now let me connect the dots, then you understand the flow now. Now how No, none of things can be breakable. Okay, after having this part, now let me again explain you the data setup. It means, let's say we have one CA again, GoDaddy. Okay, DA, what I'm saying would be, and this is the client. Let me use the word called Firefox, for example. Okay, what Firefox know, they say, I trust you, GoDaddy. Whatever you sign, I can verify. Because whatever sign, you use your private key, and your private key is not available anywhere in the world. You keep this private because this private key. But from this private key, if you sign any document, I can verify it's signed by you because I trust you. And you know why I trust you? Because in my browser, I have your public key. You are a GoDaddy or let's say you're a CA. I have your public key. From this public key, because anything signed by you, then your public key can all is the only thing can verify it. I can verify before I use it. Okay, so this part we have. Now, let's again same thing. We have a server, again Gmail is one server, and server has their own private key. Server has their own public key. Now, now Gmail is one company, or Linux is one company, and they know, okay, that everybody in the world trust on GoDaddy, on the CA. Okay, but they never trust on us. They might trust on us, but they might be some hacker create the same Gmail. Technically, they doesn't trust on us. Okay, so what Gmail will do? Gmail will create one certificate, send to GoDaddy. This is called CSR certificate, certificate sign request. Main thing in the certificate is Gmail or server public. GoDaddy will sign it and create one more new certificate or CRT. Okay, so finally your server will have the CRT. But what CRT contain? Two main things. Is contained actual Gmail public key, server key I'm noting here because server key has been sent to GoDaddy, and here they put the stamp, means the sign. Who signed? GoDaddy. Okay, and why GoDaddy can sign? Because GoDaddy have their own private key. So this has been sent to Gmail, and say Gmail, if you're hosting a web application or your web server, for example, like Apache web server, okay, and your customer want to communicate with you encrypted way, okay, so give this certificate to the customer. Okay, the certificate is called CRT, but let me use the word called certificate. Main thing certificate, two things: Gmail public key and your CA only signed. That's all. Now, in this case, now Firefox is trying to, or you as a client trying to connect to Gmail. Okay, first thing when you hit first time, okay, the Gmail will hand it over what? The Gmail certificate or server certificate. So server will handle their certificate. Okay, and what you will do as a client, in this certificate, you will find server public key. Okay, and what you use of public key, you guys know, you use public key for the key distribution. Means client will create a shared key for further encryption and lock with this, the way I show you in the hybrid part. Last time, today also I very quickly explain to you. And last class I show you with the practical also. Okay, but before they do this operation, they have to check in this certificate, whatever the server public key come up. Okay, does this public key is actually coming from Gmail? How we know? Actually coming from Gmail. Okay, how we know? So for this, my client, my Firefox will say who signed it, who signed this certificate. This is like a doc. Who signed this doc? In this case, is written, it's signed by GoDaddy. So Firefox say, do one thing, let me do for one thing. Let me first verify the certificate because I already rely or believe and trust on GoDaddy. Why? Because I already have the GoDaddy public key. and that I don't have to download from internet, means no of the hacker can do man in the matter, then nobody can spoof it or temper it. Is there in my browser. So I'll keep this, I'll take this public key of my CA and let me verify this document. And I check the signature. The public key is only one of CA, can check the sign of the CA. If the sign is done, is right, it means this certificate is actually signed by GoDaddy and GoDaddy is reliable. Okay, it means this document is this it means public key inside this document is actually belongs to a main Gmail server. It means this is the right public key. And after you got the right public key, then the problem has been solved. Okay, then after this, the remaining, we can create our symmetric key in AES or symmetric key algorithm. We'll lock it with the Google or Gmail public key or server public key, send it. They are the one who know their private key. They can decrypt, and both the guys will get a symmetric key. After getting symmetric key, everything will be completely encrypted. Okay, encrypted. Okay, but in this example, if hacker is there in the man in the middle rack. Okay, and they spoof or do the spoofing here or the phishing attack the way I explained to you already. Okay, client can very quickly check it. How? Let me do very quick this diagram. This is client, this is server, this is hacker. Okay, my Gmail server has a certificate signed by CA. Okay, hacker has hacker private key, hacker has hacker public key. Okay, but they don't have a certificate signed by CA. Okay, so in this case, client will go to server to Gmail, but maybe hacker can do a route poisoning here, and packet will be sent here and say, hacker say this is IP 100, and they say I'm your IP 100, so I'm going to give my public key to you. Okay, but client say no, I don't rely on the public key, I need a certificate. Okay, I need a document where I will see the complete detail of the company plus the company, this server public key. I will see this. I need this. Okay, so hacker don't have. But let's say hacker can create their own certificate. Okay, because creating certificate not big deal. Today I'm going to show you also. You guys can also create a certificate, right? So hacker can also create their certificate. So let's say hacker can also create a certificate. Okay, so here hacker can create your own certificate. Okay, own certificate. In the certificate, they can put their public key, and because they can create their own certificate, they can put the same complete details. Okay, what this company, let's say Gmail has. Okay, Gmail has. Okay, what they put? They put I am IP 100, this is IP 100. Okay, so they put the IP address, they put the same address like Google, Mountain View, Silicon Valley, all the same thing they put. Only thing they put it, hacker public. So they again create the same certificate CSR, and hacker know that everybody rely on GoDaddy, for example. Hacker send this certificate to GoDaddy and say, you are CA, everybody rely on you. Can you please sign the certificate? So first thing your CA say, no, I want it. Because right, you are putting the IP address, and we know IP address can be spoofed. I want allow the IP address in the certificate. Do one thing, wherever you hosted your server, okay, you have to put your host name or the domain name. Okay, for example, Gmail hosted here, Gmail will put the gmail.com, the gmail.com or www.gmail.com or mail.google.com host name. Okay, so you have to put your host name, but hacker plan is to create a website like a gmail.com So they will put its IP address, they will put www.gmail.com as a name of the server. Okay. And when the CA, the certificate go to CA say, hey, I rely on you. You send this domain name, okay, to me. Okay. I will sign, but I have to verify this domain belongs to you only. You are the owner of the domain. So whichever the registered email ID of this domain, I will send a mail to you. And please verify it. So if domain is really registered with you, you can verify. Or maybe if this domain is really registered with you, so you have the DNS report. So I'm asking you to go to DNS and write some entry in the DNS record. So either you put the DNS record because you are the owner. If you're owner, you can do it. Or I will send an emails to you in this domain, or in your support email ID, whatever ID would be, while you're registering the domain, you can go and verify it. So this is called DNS verification or email verification. Or this company is very big, I come personally visit your company. This is a personal verification or physical verification. So multiple different ways CA can verify. But interesting thing is in the real world, okay, if my domain is vimal.com, nobody in the world can have the same domain name. So my DNS can only maintained by me. My email is already maintained by me. My company address is physically is there at my location. So however CA is going to verify, they can very quickly come to know, okay, this sign asked by hacker, okay, they are not owning this domain name. Because finally, okay, one more guys point I want to add here is, if any client who, let's say Firefox, if they want to communicate to anyone, they use the certificate to get a public key. Plus in the certificate, they also have to give the server name also. Server name may be IP address or the host name. A typical pattern is that we always give the DNS name here, not the IP address. Okay. For example, if you connect to google.com, okay, google.com. So I am a client. Okay. I first take the Google public key from the Google certificate. But with the same time, I also check the certificate attached with the IP address or the domain name. So for example, if you click here, you can see a certificate from here. This is the connection secure. If you click here, this certificate. Okay. And guess here is issued to DOM, google.com domain, your DNS name. And this is the only company in the world who has this domain. For example, my domain is vimal.com or lanceworld.com or aldoindia.com. It's owned by me. Nobody can own it. So CR Smart, they say, if you are claiming this server is hosting an IP address, first of all, we don't support IP address. And every IP can be spoof, but every IP can have a host name. For this, you have to buy a domain name. And we know in the domain name registry world or domain registered, they won't give two domain name to two different companies, same domain to different company. So if you say your gmail.com is owned by you, that you have to put in the certificate with the public key, I will sign, but prove it. I will verify by sending mail or by asking that put something in the DNS databases, some record. I come physically, multiple different kind of verifications they do, but none of things hacker can do because they are not owning this domain name and the email address and the physical address. In this case, CA will not sign it because normally CA will take a price, but hacker can give the price or charge, but they won't verify it and they deny this certificate. Okay, so in this case, the client always looking for a certificate when you connect first time. Hacker don't have certificate. So in this case, hacker can be more smart. Hacker can create their own personal CA. Hacker's own CA. In this case, hacker can create your own certificate. It's called hacker CSR. Hacker send to their CA, their own personal CA. Obviously, they can sign their own CA certificate, then give the CRT here. So finally, hacker has their own signed certificate, right? How? Well, from their own CA. In sign, they have their own public key, or hacker can put the name www.gmail.com in the certificate. They can put. Okay. Because they are on CA, that's how obviously they can sign, right? With the same domain name. They won't verify. But in this case, now when client come to hacker and say hacker, not obviously client doesn't come directly, but hacker will do in the middle attack or some kind of phishing. Okay. So when client it took the hacker system and say, I'm looking for your certificate, hacker will send the certificate. And beautiful thing is that it will look like a real certificate. Okay. That is been having the hacker public key, has been signed. They can see www.gmail.com, gmail.com. That's what the hacker client is requested for, google.com, gmail.com. Everything look exactly same. But client is smart, not directly, but client browsers are smart. Okay. They say, I have to verify the certificate. I have to verify sign of it. And for checking sign, I need to know who signed it. Who signed the certificate? Okay. So here, obviously, this signed by hacker CA. But this hacker CA is trusted? No. Trusted means, does hacker CA public key is already installed in the Firefox? No. So whoever built the Firefox and Chrome that point in time, they know GoDaddy, they know DigiCert, all the things. They don't know hackers one, right? So they also, guys, by putting is they go physical verifications of physical audit and all the things they do by putting it. And obviously they won't go to hacker place to understand to put their certificates. So client browser say, I don't know, you are signed by CA, say a name you're talking about, but I don't have their public key with me. I don't rely on you. So this certificate is not valid. I won't take public key from the certificate. I won't do further communication on this. Okay, I will stop communication. Or maybe my browser will throw the error that this is not signed by some CA, so fake. If you want to continue with it at your risk, the cloud browser come up. Otherwise, by default, we won't connect to this certificate. Okay, so my point here is any point of way you try to think, it won't be breakable. Okay, and this is possible only if you trust on that CA who signed the server certificate, and our browser trust on these list of certificates that I already showed to you, these certificates. Okay, so any company in the world who want to do work on HTTPS, they want their communication to be secure with the client, they have to sign by these certificate CAs, like verifying or these few 10-20 names they have. Okay, now challenge here is, guys, again, I think this entire part has been clear. My point here is, this is the client, this is the server. Let's say this server of Linux world, and this is so 10-20 CAs, only 10-20 CAs, not much. If you see here, these are the only CAs. If you had 10-20 CAs around, and all the browsers in the world trusted. Okay, let's say Firefox. Okay, so these trust these CAs, for example, GoDaddy means they have the GoDaddy public key. So if Linux world wanted to host their website and want to do encryption, okay, and they want their public key reach to the client properly, server public key, okay, or when they reach, they can very quickly verify this is a real public key or not. Okay, so server will create a private key and public key, and also I explained to you, this will send a certificate request, CA will verify and send it back. But how they verify? For verification, there's 3 different methods they have. While creating a certificate, Linux will create a certificate, Linux will put their public key plus their company details, let's say contact addresses, all the things, plus this server is going to host in some public IP address, for example, or maybe private IP address. But this server, because nowadays, guys, all the client don't use the public IP, right? Instead, we use the domain name, but you can use public IP. But in security world, it is compulsory to use the host names instead of the public IP address. Okay, or it's called also known as DNS address or DNS host names or DNS names or domain names. Okay, so this server, if you want to work on HTTPS or the encryption, okay, obviously client finally use public IP, but client have to use, and you have to give the client your host name. As a client, if you want to connect me, my URL content would be HTTPS for encryption, and colon instead of IP address, I'm going to give my host name or the domain name. Okay, you have to connect with this. Why? Why? Because whatever you type, you go to DNS of centralized DNS. Okay, and from the DNS will give IP address of mine. You reach to me. That's what the duty of DNS. But when you reach to me, okay, okay, in the packet. So in the encryption world, we have to ask our client. We never give the IP address. Guys, if you see Google, Gmail, Facebook, they never give the IP address. They give the host name, right? And we ask the client, type the host name, the URL. Why? We type the name. Obviously, you can't connect with the name, but you will hit to DNS. DNS will give the IP address. But when you reach to server on the IP address, or because you are doing HTTP request or HTTPS request, inside the packet, this name always go. So when the packet goes to server, okay, what a client type in the URL, the host name also go as HTTP header. The client type this name. It means, okay, this name is asking server that I need HTTPS, means encryption. Okay, and for this, I need a certificate, but you might have multiple IP, maybe you might have multiple name, maybe I'm not interested in any of the IP or name. I need only a certificate that you have with this name associated. So you are creating a certificate. At the time of creation certificate, okay, what are the host name you put in the certificate? Same host name you have to give to the client. And when the client is coming to you, you have to give only that certificate that has been associated with the host name. Why host name is important or DNS is important? Because when you go and ask, give the certificate to CA, okay, CA will verify your certificate either by email. They will send the email on this domain name, or they will verify by asking, does this domain name DNS you on, update some record there to check, so I can check this is owned by you. Or maybe if you pay more for a certificate checking, then they might come to physically at your center. Is a different way of checking. But CA will verify only on this 3-way, and then only the sign. And they give final CRT, that's called final, the CA stamped by or signed by CA. Okay. Mostly, not always, mostly 99.9% certificate in the world signed by CA by looking at the host name or the domain name of the server. That is a reason your server might have hundreds of IP, maybe one IP, maybe, doesn't matter. Okay, whichever host name their certificate has been signed, or inside certificate I can say which host name we have put. Okay, same host name we have to give to the client. Okay, otherwise it will fail. The browser will say, I requested for www.gmail.com, you send m.gmail.com. No, it won't work. It will fail. They say it's not been, what domain name I connected, you given the different certificate, maybe signed by CA, everything good, but host name is not matching, it will fail. It should be matched. So guys, when I do setup, I will show you this entire process, but I'm just giving you that also one of the point. Why this point is important? Because I told you, hacker can also create a certificate and ask to sign. So Go did it the way I was trying to explain you. Okay, so how Go did come to know? this is not belongs to you. So they make it this field compulsory. Okay, that how can I identify you that this is belongs to your company? So they use a domain name normally to verify, or email address to verify. Email address again belongs to a domain name only. Okay, this is also one point. So this is guys one point to be known. The only last challenge is I would like to explain you very quickly. Then I would like to go very quickly to the demonstration part of it. So in this last setup, last point, only challenge is in this world, we have millions and millions of websites, everybody running on the encryption way, but we have very limited CA available. Let's say around 10 CAs we have. Okay, in this world. Okay, so how all those 10 CA, only those 10 companies can sign those millions different certificates of different websites, so millions and billions maybe. Okay, so they can't do everyone checking and signing. All right, so what they have done, these are the top 10 or top 20 CAs. They are the trusted CAs. Okay, trusted in all operating systems, let's say in the browser, for example, Firefox. So these guys, your client programs know these CAs, they are trusted CAs. But they can't do everything by themselves. There's those many signing. So what they have done, they have created a lot of sub CAs or intermediate CAs, or maybe I can say sub CAs, sometimes also known as intermediate CAs. Okay, and give and hand over this duty. Now what you do, you go and sign the certificate for the servers. Okay, servers. So these companies create a lot of give their job delegated or delegated to other sub CAs. Okay, other sub companies, or they have multiple branches, multiple partners, multiple different companies, or they give these options to their, let's say in one company, let's say XYZ is a one big MNC company. Okay, and this big MNC company has to host thousands of websites. Every website they have a different name, different time they sign. They say, I don't come to me by again and again. I am making you as a sub CA. So all the company, your internal certificate you sign, internal server certificate you sign. But are you trusted? To all the kind of world, no. So what I'll do, when you sign your internal server certificates, okay, that point in time, also mark me, also use my stem also. I'm giving my stem uses authority to you. What I mean by this, I'll explain to you. Something like this. But in this entire world, this top CAs who is been known by everybody are known as root CAs. So hierarchy, guys, it will be something like this, right? In the world, we have top 10, 20 root CAs available that has been trusted by everybody in the world. These are the some name I show you. These are the root CAs, trusted root CAs. Okay. And they say, let's say you are one company, and I'm taking a one name called IBM, for example. IBM is one company. This company has lots of servers running, have their own domain name. Let's say A domain name, B domain name, C server, D server. Everybody has to sign the their CSR. They have their own CSR. They want to sign. Rather than they all thousands of computers go to root CA, give a lot of money, a lot of time it will going to consume. So IBM internal company, internal team or security team, what they do, they sign their own servers certificates. Okay, so the IBM can create their own CA, for example, the internal company CA, for example, internal CA for the company. Rather than they go to root CA again and again, take the time, take the lot of monies, they sign their own certificates. But again, the challenge is, okay, the actual client on the internet, like Firefox, they trust this CA, let's say this is GoDaddy, but they doesn't trust IBM internal CA. It will be like a hacker. just to understanding for understanding. Means whichever inter server they sign. For example, this may be www.ibmquantumcomputer.com website. If this website want to work on encryption, IBM is signed. But their stamp is not known by me. Let's say I am Vimal. It's not by Vimal. So when I hit to the website, I say I want to use you, but you have been signed by some CA, IBM. I don't know who are this. For me, it is not trusted. I want to have a look at you. I want to do any encryption with you. So in this case, this is genuine CA. They are genuine signing their own server. For this internal CA, okay, have to get approval by this root CAs. Okay, and root CA is the one who say you're approved. You can be approved CA. You can sign the certificates. In this case, these are known as sub CAs or intermediate CAs. How they prove? So when I guys explain this concept in practical, that time I tell you how to make the intermediate CAs. So a lot of use case of intermediate CAs. One of the root case, one of the use case, not root case. Use case would be, this is one use case that one company say, I would like to create my own personal CA. I want to sign my inter servers. This is one use case. Other use case, some company want to start their business as a CA. Okay, as CA, so they can sign other servers certificates. But this company is not known by anybody. Okay, so this company has to get the first approval from this company as a partner, or some kind of monthly, yearly amount they have to pay. Okay, then only they can further sign. Okay, and then only any certificate signed by this guy can be known, understood by this guy. Okay, so technically, so how it work? By the way, guys, this concept is known as this is root CA, there's sub CA, and again we can add one more sub CAs. So like big hierarchy also we can create. But this is not a chain of CA. Guys, this is also chain of CAs. Okay, but your final client browsers only know root CAs. So that is a reason how the process work. Okay, if you have the root CA that is known by everybody, then you create sub CA number 1, then you create again sub CA of this sub CA number 2 due to any of the plan. Then you have final server, your actual server, web server, for example. So this web server has been signed by this guy, but nobody know this CA. So this CA is been signed by this CA. That now CA2 has been approved by CA1. Again, nobody knows CA1. So this CA has been signed by root CA. The CA1 is approved CA in the world. They can sign other one. Okay, but root CA is known by everybody in the world. By browser, that root CA certificate is there. So chain. So finally, in your final web server, the final certificate of web server. Okay, for example, I am a client. Okay, when I come to this web server and ask me to give the certificate, the server will give me a certificate signed by this guy, plus this guy, and plus this guy. So as a client, you will see the entire chain of certificate comes to you. And in the entire chain, you have to only check, do you know this? No. Then go up. Do you know this? No. Then go up. Do you know this? Yes. I mean, somebody you know, somebody trusted. It means if you trusted this, then you will trust this, you will trust this, and then you trust this. The entire chain of certificate always come up to your browser. Okay. If anything you know, then it means you are trusted. Okay, and that is a reason, guys. And nowadays, mostly you won't see any of the server directly signed by root CAs. They have been signed by their sub CAs or intermediate CAs. And it means any website you open, any website you open, let me take any example randomly, maybe let's assume this website has been signed by one CA, right? How? First of all, this website is secure. How I know? The symbol. When I click, this site is secure, means it's been signed by some CA. If I click the CRT, it means the certificate here of this website. Okay, you can see certificate path here. And now from here, you can see this website, zoom.us something. Okay, this is your Zoom website certificate, server certificate. This is the one who signed this. Okay, this was sub certificate or sub CA, sorry, or intermediate CA. And this intermediate CA has been signed by this root CA. Okay, this is how is a chain of certificate always come to. Or for example, let me check. I don't know who signed this. So lw.com. Okay. Whatever. It's not opening. lw.com. Okay. So you will always see this chain. You won't see, for example, if you go to Facebook by the meantime, if you click here and if you see the secure certificate valid path, this how. Right. So Facebook is signed by DSR, some assurance server CA. Okay, this is sub CA. Then this is the root CA. This is how you will see. In almost you see. Maybe you can see somewhere. Maybe in the example, this website secure. See the certificate. This is a path. So here we have multiple chains. Okay, so for example, if I try to explain from this point of example, so we have one server, lw.com, this website. This website is being requested by a client. This is server requested by a client. Now, in this case, the client is me, my browser, let's say Chrome. Okay, and I want encryption. Hand it over certificate to me. Okay, so this website handed over the certificate. This is what certificate is. Okay, in this certificate, what they have, by the way, this is known as CRT. Hand over the CRT. What the CRT content? One, who signed this certificate? This CA. But my browser doesn't know anything about CA. I can't verify this CA. Okay, so I can say I can't verify public key of this lw.com from this CA because I don't know the public key of this CA. So I can check. Do I know the above one? So again, I don't know about this. Okay, to verify this CA, I need a public key of this. I don't trust this. I don't have the public key. But to verify this, okay, I will go up here and check my browser. Do I know Sectigo or something public keys? So I trust it. Answer is yes. So if I show you again my browser and in this list again in the settings, okay, somewhere you will see in the root CA, you will find some name, maybe connected this, so we can find this name somewhere. Okay, Sectigo and something like this. Or maybe they have again further connectivity, but you will find this name here, or maybe here you find this name somewhere. Yeah, here it is. Okay, here it is. Maybe somewhere I downloaded it already in intermediate, but this is there. Okay, if this name is not there in a browser, okay, finally website will fail initially and say I don't trust it. Okay, continue with your risk, but it is not genuine website, is not trusted. You can see some kind of a red mark also come in the top in the browser. It's been not secure. Okay, this is how it works. This is one thing. Second thing is, if you go to this website, okay, here the symbol means whoever gave the certificate, the CA who signed it, I know the CA. CA trusted, there is this symbol is come up. This is one of the reasons to have this symbol. One of the reasons. Okay, and if you open the certificate again, okay, so this is a path of the CA, means the chain of CAs. Okay, but this website has their personal certificate, this personal certificate. Okay, and you can see the personal certificate in the details. That this is how certificate look like in the simpler form. Main thing in the certificate is public key. So this server has given this public key to us. But this public key is right, it's not hacker public key. How? Because this entire public key and the entire part of it has been signed by these CAs. This CA and this CA, this CA and this CA signed by this root CA that I know. Verify, right? Otherwise, there's a lot of things also there. Okay, for example, here in this certificate, this certificate has been signed by this name, lwindia.com. Okay, so otherwise there's much more things over there. When I create this, when I create the certificate right now, you can see all these things right over here. Okay, and plus also some basic general details that show you. Main thing is the validity server certificate of 1 year, because I pay this company who signed is an intermediate payment for 1 year. So they sign for 1 year because there's a charge. Okay, and they sign for this domain name only, domain name only. So when a client come to my server for this domain, I'll share to these guys. If they come for different domain, or I wish if I share this one, they will fail, or vice versa. Okay, so when I create right now, you guys can see this is what is happening. But this is, guys, the entire concept over here. So this is a very powerful setup. It's called complete PKI, and this process of entire, this entire process, the entire process from where client start communicating to the server. Right now, server has a certificate called CRT. Okay, so first communication will be client connect to server and say, I need certificate, server give the certificate. Now from this certificate, first server check who signed this. They find the stamp or the signature. That is also known as issuer. So if you see in this website again, okay, here they see this certificate. The certificate is belongs to Linux Word. Who signed? This guy signed. Or you can say who signed? This guy signed. Or here also we have the option here is issuer. Who signed this? This guy signed. Okay. But does my browser believe on this? No, my browser doesn't know anything about this. So we'll go inside the certificate, say view certificate, inside the CS certificate, and say who signed this. So this is signed by this guy. But do you know this guy? No. So again, we go again in the certificate and say who signed this? This guy. Okay. So do you believe on this guy? And says yes. In my settings, I'll show you guys the certificate already there. I know this guy. So this guy, verify this one because I know public key. So I can see the signature of this guy. Verified. Then because now I verify, I now believe on this. So from this certificate, I can get this CA public key. I can verify this certificate of the sign. And again, this is verified. It means this public key, I again now start believing. Now from this public key, I can verify this public key. This public key. Okay, this public key that I seen here. Okay, or that certificate I can see. Like a chain, right? So it is how it will work. So even though, guys, same thing you can do from command line also. We have a very interesting command to see the entire chain. So if I open my command line tool, okay, command line tool, there's an open SSL command, you guys know. And there's, guys, one option called s_client. So you want to connect to any client securely from a client to server. And then if you only want to check the certificates, so the one keyword called certificates, and you want to connect to one of the server, I say yes. To whom you want to connect? Again, I want to connect to www.lw.com or netflix.com or google.com. So when you connect, you know what happens? There's a command line tool. This command will show you this entire chain. Entire chain. This chain. This and this certificate, this certificate, this certificate. So either you can see from this browser or this command also we have to see this. Okay, they show you. So this is an interesting command open itself to see the chain of the certificates. But I know guys, you're not working. Why? Because you guys might know any website that you open with HTTP, they work on port number 80. Any website that work on HTTPS, they work on port number 443. Okay, so here guys, I say I want this website to connect on port number 443. When I hit enter, now I can see lots of data gonna come up. And if you try to see, you will see that lots of people will come up, but you will see that if you connect to this server, you have connected. Okay, and this server certificate has been signed by one CA. Okay, one CA. But it is not like the root CA, it is chain of CAs we have, certificate chains. Okay, so this website certificate is this one. Here, CN means common name is who belongs to this service. So this is the one certificate. Okay, come into the encoded format, but this is a, if you come a clear text, it will be something look like and much more like proper text. So this is one certificate gonna come up of my CA, of my server, and this server certificate is changed by, is been signed by this CA, but this CA has been signed by this CA, and this CA has been signed by this CA. Finally, say Tico name gonna come up. Okay, and by chance we know about this CA, so there is no further name gonna come up. Okay, further name gonna come up. As such, there is nothing gonna come up because we know already about this CA because this CA is there. Trusted in my browser or maybe in my operating system also. So there's one chain gonna come up. So you can use this command to you control C to stop to see this chain very clearly. Somebody one chain, somebody a lot of 2 or 3, 4 or 5 hierarchy, everything you can see. Okay. So this is one thing. So yeah. Now when this certificate reach to the client can verify this certificate and all the chains of CAs, and finally they verify your server certificate. That's the main thing. After verifying server certificate, then they get the server public key, and further communication will be same. The client will create us on shared key. So client key, for example, they log, then they send this data to server, and client key or shared key has been logged by server public key. Server has their own private key, is not shared by anybody. They use this to unlock and they get the key. Both will have shared key. They will do the further communication with the pure symmetric keys. That will be very quick and very secure also. This entire process from this line to last line is known as handshaking. So we are doing handshaking from server to the client, and this handshaking, the older way of handshaking is called SSL, but it's been obsolete, secure socket layer. Okay, they had a lot of issues. Nowadays, the latest way of doing handshaking is called TLS, transport layer security. But whenever you will read the term SSL, it means TLS only in today's world. But nobody uses SSL nowadays. Everybody use TLS. Mostly they use the version TLS 1.2, but now one more version also come up. It's called 1.3. If we get the time, I will definitely tell you the difference. Okay, but mostly we use 1.2. But nowadays, 1.2, I have one small issue. Okay, that has been solved by 1.3. Even though if you see here, this website also using TLS 1.2. Okay, so when you say SSL is now a very common name because SSL is very old, very commonly used this term. So till date we use SSL, but typically it is known as TLS. Okay, so when you heard SSL, it means TLS, or mostly we use SSL TLS or TLS SSL kind of handshaking. Okay, but even though guys we have this powerful setup established, there's a way we can also break this entire PKI setup or this entire TLS setup can also be breakable. How? I'm not discussing right now. I'm giving this task to you. Just go and figure out how this entire setup where we have multiple CAs, my browser know the CA public key already. They get the signature checked. They can get the server public keys. Okay. Even though this setup, we have a way we can break. How? You guys think? Just go and check. Means you just try to figure out. Maybe I will try to show you somewhere when we got the time. Okay. But let me have this setup. Let's do the practical. A lot of concepts I explained to you. Okay. Now my plan would be something like this. I'm going to set up one web server here. Okay. But this web server, I'm going to create a private key. Then I'm going to get a public key. And I'm going to put this public key in one certificate. This is called CSR. Then I'm going to send this certificate to one CA. Why I'm not going to create direct or root CA. I'm going to create an intermediate or the sub CAs here who is going to sign this. Okay, so I'm going to sending as a request, and they will sign and give me back a signed certificate that is called certificate, also known as CRT. Okay, but who is going to connect to my web server? My client, my browser, let's say Chrome browser or Firefox browser. Okay, so when they connect to the server, they ask, I need HTTPS connection, means secure connections, maybe an HTTP, FTP, SSL, whatever would be, SMTP. Server, can you send a certificate to me? This because they have the CRT certificate given by CA. So server will send the certificate to the client. So client always looking for the certificate. How can I see this? You can use WireShark also to check. So whenever you connect first time to any website or HTTPS, okay, they are looking for. Let me enable all the more. Multiple interfaces I have. Let me call, you can say one. So I'm again using Wi-Fi connection character here right now. Let me connect. I say allow. Reading traffic. A lot of traffic is coming up. So what I'm going to do, WireShark is a tool I showed you already in my last class. So I am going to open a new tab and going to open this website again. And the HTTPS, as you hit first time, my client. Okay, but even though before this request is open, let me pause my this program. Okay, so when you open this website first time, so I'm a client. When you open the first time, okay, your request to server, you always ask, can you give me a certificate? Okay, so if you see here, a lot of data come up, but let me search for TLS packets only. The TLS packet, and you see in the somewhere in the last. Okay, when I hit to one of my website, okay, somewhere you will see a lot of data is coming. So if you see guys, this is application data, means my data is coming here, but this is what guys the request is. I think this may be because there's a lot of other combinations also going on right now. It will be anything. It may be this one. Okay, maybe this one. So from here it will start. So this, because I think the website that I opened, this maybe this is the IP of the website. Okay, so let me use IP address, not that one, TLS. So I want to tell you, even though let me take this example, doesn't matter. This one. So somebody from this IP connect to this IP, and first time you send client hello. Okay, so what is go from my laptop here 1.12 to this IP? This is my laptop IP. What other side would be? You ask, I want to do a TLS handshaking. In this case, website they connected, they use 3.1 version of 1.3 version of TLS. If I say I want to do handshaking with you TLS, and what I want, okay, I would like to connect with me, okay, and guys, I will explain sometime what are this, but technically they are asking, they are requesting, okay, yeah, they're requesting for the certificates, okay, the certificate, and next request, this server send you back, right, this thing. They say you that this is some again, this might be not actual thing what I'm trying to tell you, but because we might already have this certificate already installed in my system, because the server certificate I connected. So my point here is when you connect first time, because this website I already connected maybe, but when you connect first time, okay, your server will send a certificate to you. Okay, that's what I might wanted to show you. Okay, but in the certificate they have a they have the they can't directly rely on. They will first verify the sign, and from here they will see the sign I show you already, and they see the signature of sub CA, but sub CA is not known by my client, so that won't verify. So only sub CA won't work. That's what I'm trying to tell you. So what I'll do, I will create one more CS for root CA. Now there's two possibility. Either this sub CA, you can go to the real root CA and do some documents agreement and get them verified that you can be a sub CA, but they won't do, obviously, likely. So what can you do right now? You can create your own root CA and sign the sub CA from the root CA. But again, this root CA, because you are going to create, it's not known by your client browsers. So this root CA certificate I will manually copy to create trust between your root CA that you're going to create with your browser. So in your browser, okay, your browser doesn't trust your root CA that you're going to create today. But here I will manually, in the setting, I will manually verified our own personal root CA so that they can trust on us. So here I will install over here. This I'm going to get root CA with my name, Vimal root CA. So it will become up here. Okay. So, but it will work in your browser only. Obviously, no other third-party company gonna use your root CA. So, but something like that I will going to do in the demo, right? So let me go very quickly to demo. So I'm going to create a guys entire chain of certificate. I'm going to build the entire PK infrastructure that I'm going to tell you. That's what I'm trying to tell you. So let's go very quickly. First, I am going to build a root CA. After this part done, then sub CA. After this part done, then I create a server certificates. After this part done, then I will use a client and connect to server and do a secure communication less than HTTPS. That's what I'm going to do. So this change, let me create. And for creating the chain, first you have to create a root CA. Okay, so let me do this step. It's been long practical actually, guys. Lots of things we have to create. Let's see how far we can reach today. My plan is to complete the class today, but it's go very long. And so let's start from here. Root CA. Okay, so one operating system guy I already launched. Where it is? Here it is. Been launched. Typically, the good practice is this root CA would be in different computer. This sub CA will be in different computer, and server obviously in different computer. Okay, but in our demonstration, I'm going to do all these three setup in the same computer. Okay, that's what I'm going to do. Okay, so this is my operating system. Okay, let me do connect. And for connection, this is Red Hat. I can connect directly. So they give a command to me to connect and use my get bash. And I have the key that I already downloaded in my download folder. Let me use this command to connect. Let me log in the root account. And I want to make this system as a root CA. Okay. So what to do in the root CA? Two things. One, you have to create a private key, because private key is the only identification in the world that you have, and any system has. And second, we have to create a certificate here of the root CS for CSR and signed by somebody to become CRT. Okay, but who will sign? Root CA means nobody is there on the top of this. Okay, so the certificate of the root CA is signed by root CA only. Same guy create and same guy sign. And anybody who create their own certificate and sign their own, they are known as self-signed. So root CA is one example where you always do a self-signing. Okay, but yeah, sub CA, you create a certificate but signed by root CA. Your server, you create a certificate signed by sub CA. Root CA means there is nobody on the top of this. That is meaning of root CA, right? But you can create one more CA on the top of this, then this become a sub CA, and then would be root CA. But whoever the root CA, they will sign their own certificates. So two things you have to do in the root certificate CA. You have to first create a private key and then create a CSR and signed by you all, signed by root CA only. Okay. So for this, there are a lot of things you have to do. I'm going to create a separate folder. That's a PKI folder, just a name. In this folder, I'm going to create a different folder for root CA. Okay. And in this folder, I am going to create private key first of all. So it is good practice. In this folder, I'm going to put lots of things, the certificate, the signed certificate, and much more things. Okay, but right now I'm going to get separate folder just for management. I'm going to get a separate folder called private, and this private folder I'm going to use for keeping the private key of the root CA. And how to get a private key, you guys know. We can use open SSL command to generate a private key with RSA, another algorithm that you command you know already. Okay, I'm going to create a private key in a folder called, let's say, ca.key. Okay, or maybe I can give the name for root ca.key file name. We can give a size, let's say 4096, something very bigger size. But guys, when you enter this, the CA certificate has been stored in the clear text in your local system. And guys, you know, you might understand, if anybody break any root CA in the world, private keys, lots of part of the internet can be breakable. Okay, because if a 10 CA is around, if one CA certificate will break private key, so maybe 30–40% traffic of the internet can be hackable. Okay, so there's a good reason. That is reason root CA always store their private key in the encrypted way. So we can use some symmetric key here. And this command will show you like 256. So this is AES 256, for example. This private key is stored locally in my system, but in the encrypted way. So nobody can, by chance, copy from the system, but they can't get my private key actually. Let me give some password. So this is what, guys, the private key of the root CA created. The same command what we see already. Okay. Now what to do? Now we have to create a CSR. So when I say CSR, it's a certificate, and what CSR contain, it also contain public key. So when you create a certificate request, it automatically create a public key automatically. Okay, so let me create this. So for this, okay, and for this, you have to use some configuration file for the CAs. CA has their own configuration file. There is not by default available. For this, we have to install a software. Okay, and name of the software is called Open SSL hyphen lib. So what it will do, it will create a configuration for a file of CA. What a user's config file, in a minute I'll tell you. Okay, this software will create a one configuration file that is located in this folder etc pki TLS. This is the configuration file. This conf file has lots of CA related settings, certificate authorized settings. So whenever CA signs something, okay, there's a lot of default settings is there in this file that we need to use. Okay, so what are default settings? I will explain you as we progress. There's a lot of default settings we have. Okay, so this file is very important. Okay, so what I'm going to do, this file is there in this folder. This file I'm keeping in a folder, this file, and I'm keeping the folder called PKI root CA folder. Why? Because typically in the real world, we use one single system for one CA, root CA, second for sub CA, second for next sub CA. So one single file at one location will be okay. But my plan is in one single computer, I want to do all the things. So for root CA, I need a different conf file. For sub CA, I need different conf file. So in this folder, I'm going to copy this file. I do some changes there, whatever I need. Then my sub CA folder, I will copy the same file. I do some changes there. Okay, this is only the reason. So I copy this file here. Okay, so here we have a root CA private key, and this is the configuration file of the root CA. Okay, now in this file, okay, what is there? Okay, so what root CA will do? Root CA duty is to sign other certificates. Maybe they can sign DAG server certificates also, but mostly root CA, mostly they sign sub CA certificates. Okay, so right now I'm here in this folder. So if you go to this configuration file, what you copy for the root CA is configuration file. In this config file, let me guys install the vim command also. Vim command give a colorful text in the file. Okay, 1 minute. So in this file, okay, what you will see, they say around second page or third page, they say if you want to work as a CA, the entire setting about CA should be kept in this folder. But in my case, the folder name is different because I changed the folder for some reason. My folder name is /pki/root CA. This folder. I'm keeping everything here. So this is my root folder or the base folder for my root CAs. Everything I'm going to put. Okay. Now they say whenever CA issue the certificate, okay, you have to keep somewhere. It's called new certificate. So in the current directory, this is storing the dir variable, and say dir variable, you have to create one folder called new dir, new cert. This is a folder where whenever any CS issue the certificate, you have to keep here. So this folder I don't have right now. So I'm in the same location. I'm going to create a folder called new certificate. What is use of this? Right now is empty. But whenever any certificate signed by CA, doesn't matter root CA or sub CA, okay, so we will keep here. We can change the name, but this is what by default we have. Okay. Second thing is your CAs also have their own certificates. What certificate contain? Their public key, okay, and who somebody signed on it. For example, sub CA also have a CRT, contain their public key plus the stamp of what? Of the root CA. In root CA, they contain their public key, but sign on their top. There is no top, so they will put their own sign. but root CA has their own certificate. Okay, so that other guys can rely on it, and they keep their certificate in this folder. So this folder I don't have right now, so let me create this folder also. Okay. Then CRL is a, by chance some certificate is being stolen, been hacked. So root CA or C has an authority to make the certificate revoked. CR is certificate revoke list. So you can put in this directory. We don't need right now. I'm not touching anything in this part. This is a database file. So in the current folder, okay, whenever CA signed any certificate, either sub CA certificate or server CA certificate, okay, so two things you can sign. Either you can sign your server certificate, or you can sign your other intermediate certificates, intermediate CA certificates. Okay, but whichever you sign, we have to create a database, and database get in this file. So let me create this file. Right now, there's nothing has been signed, so this is empty. But as soon as you sign, you will see there's something automatically come up. Okay, next. Then our CA keep the certificate of their own here. Or what is certificate name? CA certificate name. So it should be anything. So I'm giving the location here in my directory in the search folder. In this directory, in the search folder, okay, CA will keep their certificate, and let me give the certificate name called anything you can give, root-ca.crt. Okay, so this is the name going to store there. I don't have right now, but when you sign, your final certificate stored in this name. Which certificate? Your CA certificate. In my case, CA is root. So this is the name of the file inside this folder that I already created, and this folder inside this diary that I already have. We already have here. Okay, that I give the name. So this is a final certificate stored here. Okay, and last thing is serial number. And when you create a certificate, every certificate give a number 1, 2, 3 counter certificate numbers. So we get the number from the serial file. So I don't have the serial file, so I'm going to create a serial file with putting 1 in this file. Okay, so right now I start with 1 is like counter. So first certificate signed, anybody have number 1, then this serial file number automatically change to 2, then 3, and then 4 is go on. This is what the number means. So there's a few settings we have done. So either your root CA or sub CA, this setting only for the CAs, you have to put these settings here. Now we are good to go. Only last thing, what we have to do at this point in time, we have to create a CSR of the CA and sign it. Okay, so how we can do? So we have a command called open SSL. Okay, I'm going to create a CSR request for REQ, is a keyword here. Okay, and I am the one who is taking the default setting from this file. So this is my config file. I'm taking all my other settings from this file. There are a lot of settings there in this file. I will discuss more in it. Okay, and for creating a request, okay, request contain your certificate. Also contain public key, because I told you public key always derived from private key, right? In my assembly class, I told you. So if you want to create a public key, you need a private key. Okay, so where your private key located, key option is located in the private folder with this name. In this folder with this name. Okay, this also is right. And because you're going to get a new certificate, so you're adding new keyword. Okay, and for certificates, we always give expiration, how long the certificate will be valid. So let me get 6536550, 10 years. This is number of days. So 10 days by 1 year into 10 is 10 years of validity. I want my CA certificate for. Okay. In this CA, this certificate and certificate, guys, you have to see, check the digital signature. And in the digital signature, you need a private key that I already given. Plus you need hashing also for get the hashes. So I need SHA 256 for hashing. Okay. Then guys, when you create certificate has their own format and name of the format. How should we look and feel look like? It's called X509 is the name of the format, or I can say standard of the certificate in the market. Okay, so the standard in the market for certificate that everybody's use and support is X509 is the standard or the format of the certificate that you have to write. Okay, and last we have to write out, means save the certificate. Okay, in this folder. Okay, with the name called what I put in the conference file. In this file, I put the name is called root-ca.crt. So the name you give, put here. You give name here. Right now, I think it will work, but in the future, there's some dependency on this name. We'll see. Okay, that's what, guys. So this is your certificate. Finally, actually, this example. Okay, this is same command we are going to run in the sub CA also. Okay, but only difference sub CA root CA is going to create their own CSR signing and then signed by their own self and can convert the CRT. This goes self signing. Okay, because there's nobody on the top of root CA. So when you see the sub CA, guys, first I will create CSR. Here I'm directly creating a CRT because there's no meaning to get a CSR here. I'm directly creating a CRT. So internally they get a CSR again until they sign it from their own private key and make the final CRT. And for this to tell that this request is going to get CSR and you have to sign the CSR and convert to CRT. Okay. Means you have to do self-signing, and for this there is one keyword that's called extensions available. And name of extension is v3_CA. This is one of the extension name. Okay, this name means that you are the root CA. You have to create your own CSR, then sign it by yourself with your own private key and convert into your own CRT. So this is the keyword that is used by your root CA for self-signing. Otherwise, it won't work as a self-signing. Okay, means you are the issuer and you are the final user. Means self-sign. And okay, and why this? What they're asking is because I store my private key in the encrypted way, so they're asking me to decrypt. Then only I can sign. So let me give the password of the private key. Okay, and guys, when you create a certificate, you have to give some details about a company. Let's say where a company located, say, let's say India. State may say in my case Rajasthan state. City, let's say in my case Jaipur city. Your company name, let's say Next World. Which department you are in? Let's say technical. Tell me something about certificates for common name. Okay, let's say I'm root CA. Here I'm giving this name, but if you see in this website, okay, the name that you see over here, Amazon, this name, what you're seeing here, this is called common name. Even though if you open this certificate also, right here, you will see a common name. So in the certificate, guys, your company store your organization name, your country name. So this CA is store this company name and this organization name. Here I store organization name Linux World, country India, and the common name that you see here or you see here, okay, is this one. So that's the name, guys. So what a name you want to show to your client as a common name of your CA, you can give. I'm giving root C. And email it is right now I'm going to put it. So that's all, guys. By this command, your root CA has been created. Okay, means I am the one who create CSR because of this keyword indicates CSR, and I'm the one who sign it, get CRT because of this extension. And now, if you see, guys, a lot of things happen. Last time the serial number was 1, we created, now automatically become. Actually, I have not signed anybody, so it's still the same. But you will see inside the certificate, this is created. This is the root CSR. This is exactly equals to what you see here. So when you open this, okay, open this. Here they show you in the graphical way. Okay, where you see the issuer name. Okay, so issuer name, subject name. If you see here, one interesting thing about root CA, the subject means to whom you issue, issuer is who issue. Both the thing will always same. See here, everything is same. But if you go to sub CAs, this one, okay, so this is sub CA, and if you see here, it's issued to me, Amazon root CA, but who issuer is different. Okay, so in guys, in always sub CA or the server certificate, okay, yeah, subject means to whom you issue means is issued to me, and issuer always your CA name come up. But root CA is the only example where issuer and subject is both the same. To whom you issue or who issue is the same. You always see in the root CA always. Same thing you will see here. Okay, I am the one who got this extension. I am the one who requested, I am the one who signed by myself. Okay, so even though you open the certificate, also you can see the same thing. Okay, this certificate is actually in the encoded way, but there's a way to decode this certificate to see the things. Right? For example, there's one command called open SSL, and this certificate is always stored into X509 format. This is the one keyword we have. Okay, I want to go in this certificate and print into the text format. This is how we can decode into text format. Okay, and now if you see, certificate also come up in the last, but if you go on the top, how your certificate look like. So this certificate, okay, is been issued to this guy and issued to this guy, okay, and issuer this one. Both the name is same, and it's valid for 10 years. I give it 10 years. Okay, and this is the public key of my my CA. In this case, root CA. Root CA, issuer and subject same. Subject means to whom you issue, is requested, and who is issued means your CA. Both are same. Okay, and this is a public key. Okay, and one more interesting thing is, because I use the extension. Which extension I use? I use this extension. Okay, and this extension say, and guys, if you want to see the definition of this extension, is there in the configuration file. In the configuration file, you will see the definition of this extension. You can also create your own extension. I'll show you in upcoming classes. But in this file, if you go down, okay, you will see the detail of this extension. This one. This extension is typically used by CA. Okay, in this extension, okay, when you use this extension, you become a CA. Means you become a CA, you can sign other certificates. That's what I'm doing it. So I'm going to become a CA, so I can sign other certificates. So this name is important, but finally in my server also I'm going to use extension, and server is not a CA. Server is not going to sign anybody else, any other else certificate. So there I'm going to use a different extension, maybe this one, where CA is false, or maybe some more extension we have. We'll see this one, use certificate where CA is false. So there are multiple extensions available in this file. That's what I'm using this file. Okay, that will tell you who your CA, your sub CA, your root CA, your final server. Okay, here I am a root CA. I am the one who going to become a CA to sign and issue other certificate. Okay, then that is the reason I use this extension. But you can also create and customize. I'll show you some example on it. Okay, so in this command again, this command is there inside the certificate folder. Okay, even though guys, if you don't want to print, you can know out this won't print. Only find output print. So if you see here, we are using extension and there CA is true. So any certificate, when you say CA2, it means you are CA and you have power to sign other CA or other servers. Okay, so if you see over here in this website, where it here, and if you pick any of the CAs, for example, pick here. If you see the details, you can see somewhere in the details. We just go and find, right? You will see they have the options. If you see the details that they given you somewhere, so you will see there they have a option as a CA true. Here they show you actually in very text format. But if you open this certificate in normal that format, what I show is called X 509 509 format. But you see there that they have the option, true. But if you open any certificate, normally server certificate, they are not CA, you will see this option false. Means you can't sign other CAs. Okay, or I can say your root CA who signed doesn't give this power to you. Okay, so when I from the root CA, when I sign sub CA, I am the one who gives the power to you that you can sign further servers. So that I will give a CA true. But when some CA sign the server CA, they will, while signing they'll say CA false. Means you don't have power to sign other certificate, but you can use your own certificate for your clients. That is one of the use of the extension we have. But now guys, our root CA has been created. I know there's a lot of things there, but after understanding this concept, this thing will repeat multiple times. Okay, you become comfortable. So root CA has been created. Here we use self-sign, but in sub CA, we will create a first request. They go to root CA, they sign, they become CRT. Log process, then the same thing we do in server. So there will be a lot of commands gonna come up. I think I need one more class for this.